super-sized scanners. Over 150 kilometers of conveyors.
Worldport is a concrete jungle. I mean, it's big.
Mega computers running monster machines. And one of the biggest air fleets on Earth.
This simulator behind me helps us keep in our game.
To ship more than 1 million packages a day, it takes the world's biggest package delivery company and the super factory, UPS Worldport. From live sharks to million-euro documents, each year, courier services ship packages by the billions, transporting just about anything to anywhere on the planet. Every day, they work round the clock to get it all there by land, sea, or air, intact, exactly when you need it. And for over 100 years, one courier has taken worldwide shipping to high-tech heights. UPS, the largest package delivery company on Earth. They process nearly 4 billion packages a year from nearly 1,800 operating facilities around the globe. It takes a massive rail yard, a squadron of over 270 jetliners, and 95,000 vehicles. All told, UPS has the muscle to ship to more than 200 countries and territories across the globe. But when it comes to the ultimate shipping factory, no UPS facility can top their Titanic hub in Louisville, Kentucky. Welcome to UPS Worldport. 370,000 square meters, 19,000 conveyor belts stretching over 150 kilometers, packages moving more than 5 meters per second, 9,000 employees. And fueling it all is an information superhighway. Worldport processes over 50 million database transactions every single hour. Worldport's the center of UPS's hub-and-spoke style sorting and delivery system, bringing everything together from outside branches for processing under one roof.
The Worldport facility is, to be quite honest, one of the most technically advanced parcel sorting facilities in the world.
Here's how the 240-hectare complex lays out. This sprawling facility combines a factory and an airport terminal into one. At the heart of it all, the core, a 4-floor processing behemoth, running conveyors by the kilometer. From the core, 3 major loading and receiving wings branch out, housing 44 docks, handling up to 100 aircraft in a single 4-hour shift. And the stats are staggering. Worldport processes more than 1 million packages every single day. Their all-time record's a whopping 2.5 million packages in a single 24-hour period. And each day, they strive to get even faster. But the mega sorting and shipping system starts at a local hub near you. It's 6 o'clock at night. American East Coast UPS couriers pick up their final rounds from clients and drop-off centers and deliver their parcels to a local hub for sorting, scanning, and entry into the UPS computer system. UPS has nearly 1,800 operating facilities across the planet. No matter what the item, before it can make its way to Worldport, it's got to go through one of these stations.
Out of here, we run about 160 to 200 cars a day out on the road. We process probably about 35 to 37,000 out of this building per day.
At the local UPS hub, sorting thousands of packages according to destination and urgency is a daunting task. Mistake an overnight delivery for a 3-day, and they have major problems. Even one digit off on a zip code can derail an urgent delivery. UPS workers know there's little room for mistakes. For UPS system engineers, tackling the potential for human error is a constant challenge. Their breakthrough solution? A computerized sorting process called Smart Labels. These simple-looking barcodes work like a passport through the UPS local system and a travel itinerary at Worldport later on in the shipping process. Smart Labels contain vital stats, including weight, urgency, and zip code. And Smart Labels live up to their name. This barcode technology holds hidden data, organized by category. First is the tracking number, the code that gives the package its unique identity. The second barcode reveals the destination's zip code. But there's one code that rules them all, the Maxi code. Within a 1-inch square, it can contain a 93-character message, from standard shipping data to detailed routing information.
We have it built this way so that if there's a flaw in one of those tracking numbers or one of those barcodes, that we can still route that package where it needs to go.
At any UPS hub, size matters. Sorting by size begins almost immediately. Every single package UPS handles is sorted into one of 3 categories. Smalls, 23 by 30 centimeter envelopes and boxes weighing less than 4.5 kilograms. Parcels, standard 6-sided boxes weighing up to 45 kilograms. And irregulars, heavy or odd-shaped items. The best way to understand a state-of-the-art courier system is to track packages in real time. Imagine our small is a notarized business contract headed for a 9 a.m. meeting. Our parcels, a valuable family heirloom, on its way to an antique appraiser. And our irregular package needs both urgency and care, a telescope on its way to a science lab. And all are bound for the same American West Coast city. One of a local hub's top priorities is separating all the items destined for Worldport. The hub needs to get a quick read on everything coming in, so they can route it properly. Here's where the packages split off, to follow one of 2 possible routes through the UPS shipping system. Local packages will go out through ground or limited air transport, but any package destined across the country or go international first needs to get on an outbound plane with a one-way ticket to UPS's biggest sorting hub of all. 8 o'clock. The team loads our packages into massive air shipping containers called cans. Each of these giant receptacles has a capacity of nearly 15 cubic meters, the size of a large office cubicle. But though the packages disappear inside, it doesn't mean they fall off the radar.
With each package that I scan, the scanner records the destination, the city, where it's going, and a tracking number. Each tracking number is connected to the can. Each can will allow us to know where this package is at.
The clock is ticking. It's time to get the cans onto the planes. All UPS hubs are strategically located next to airports. UPS dock workers use oversized tugs and dollies to haul the packed cans to waiting airplanes. Heavy-duty scissor lift-style loaders lift and shuttle the cans on board. UPS's planes load up to the brim, with an onboard capacity ranging from 8 cans to more than 60 in total. Time for liftoff. Inside, each of our 3 packages has a one-way ticket to Louisville, Kentucky, and a date with UPS's ultimate factory, Worldport. 10:15. Our plane's halfway to Worldport, but the facility's already buzzing with incoming and outgoing planes, all loaded up with cargo. Every arrival and departure here must be carefully orchestrated. Hundreds of planes land and take off at 2-minute intervals. The entire compound has to be on constant alert. Such tight flight intervals make safety a constant challenge. One wrong move can mean catastrophe. Before any plane can land here, it's got to navigate the approach.
We may have a string of airplanes that'll go out for 20 miles and they all line up behind each other like a conga line coming in.
You're feeding in from the different parts of the country. You've got airplanes landing from the west, airplanes coming in from the northeast and southeast. They're all feeding into Louisville at a critical time.
But when air traffic's this congested, lost seconds are not an option. In recent years, UPS flight operations felt they needed new technology to keep even better command and control over their cargo fleet.
Climb and maintain 1-2000, turn right heading 280.
It was clear regular radar just wasn't precise or fast enough.
Radar being a ground-based technology from the 40s that continuously looks for aircraft and sends out messages saying, where are you, where are you, where are you, to which the aircraft can respond, here I am.
After experimenting with plane tracking technology, UPS's flight operations found an answer. They now rely on one of the most technologically advanced surveillance systems in the world. It's called Automatic Dependent Surveillance Broadcast, or ADSB. ADSB's revolution comes down to strategic placement. Unlike radar station signals sent up from the ground, ADSB works on board the aircraft itself. It constantly transmits position, altitude, and velocity directly from the plane to Worldport's air traffic control.
Each airplane has its own signature on the screen. So I can see the ground speed of the airplane, the call sign of the airplane, the position it is in reference to my airplane.
ADSB gives the fastest and most accurate tracking information UPS has ever achieved, and it has a huge safety advantage. Other planes can pick up the same signals, avoiding close calls in the air or on the busy Worldport runways.
I've been flying since 1982, and I cannot understand how I was able to survive without ADSB all these years. It's an amazing system.
$30, $20, $10.
11:30. Touchdown. Our plane's on the Worldport tarmac at last. A safe landing. But now, a UPS pilot faces another hurdle. He's got to park. With dozens of planes, hundreds of people, and scattered equipment on the ground, the pilot has just a few minutes to navigate the plane into the precise loading dock in the wings. It's a challenging test of safety and skill. Trained crew members called marshalers use lighted wands to guide the pilots to the correct docking bay. There's a constant shuffle of machines and a deafening roar of jet engines. Marshalers and pilots have to focus on each other to ensure everything works smoothly and safely. It's a process called wing walking.
So you really got to pay close attention to the wings as you're walking it back. It is kind of scary to have that kind of responsibility.
The marshaller signals our incoming plane into a receiving area. Success. Another shift of planes lands and docks without a hitch. Now these same planes have to unload their cargo as our packages begin their journey towards Worldport's giant core. Worldport's exterior is essentially an airport terminal built on a mega scale. 3 wings, A, B, and C, branch off the runway. Together, they can accommodate a total of 44 airplanes at any given time. With each new arrival, dock workers unload cargo onto a network of conveyor belts. The credo here, no room for error. And the stats are overwhelming. On a peak night, 9,000 workers have 4 hours to sort more than 800,000 packages, unloaded from roughly 100 modern jetliners. The whole process must work flawlessly. Even a minor delay can slow up the entire operation. Worldport works round the clock, but the bulk of the sort happens in 2 identical 4-hour day and night shifts, from 11 o'clock in the morning to 3 o'clock in the afternoon, and from 11 at night to 3 in the morning. Thanks to demand for overnight delivery, the high-volume heavy lifting's always at night. It's the handler's turn to take over. They have only minutes to unload these massive shipping containers from the aircraft. The job calls for some mechanical muscle. There's only one way for a crew to unload nearly 115,000 kilos of cargo in less than an hour, with a massive mega machine called a K-loader. These towering 5-meter steel-constructed scissor lifts can tackle 5.5 tons of cargo at once. But for operators, wrestling K-loaders isn't easy.
It's very easy to drop a can, very easy. You have to keep an eye out to make sure no one is on the elevator. You have to make sure that your cans are lined up because you don't want to get them stuck. You also want to look out for your crew because you don't want anybody smashed.
The K-loaders lower the container onto the dock. Crews need a way to move these cans into Worldport's wings fast as possible, without getting bogged down with more transport equipment. After trial and error, UPS came up with a solution, built right into the floor itself, a revolutionary ground cover called ball mats. Ball mats are custom floors lined with steel ball bearings and rubber-coated wheels embedded into the surface.
It's bolted into the ground with 2 bolts, and it just pivots and rolls real easy, so anytime you move a container or anything over it, it slides with ease. It's a very nice system.
The ingenious design gives a package handler almost superhero strength, enabling a single person to move containers weighing more than a ton. The race to keep the cargo moving is on. The next step, unpacking the cans. Ball mats help roll the cans into the heart of Wing B. Here, workers lock the containers into one of more than 200 unloading stations inside the wings. To get every last package out of the cans, employees usually work in teams of 2. The unloaders are responsible for sending every incoming item on its way into the Worldport distribution system. Workers must sort each item by hand, dividing packages into the 3 size categories: smalls, parcels, and irregulars. It sounds simple, but with a mountain of boxes, each with unique instructions, it takes focus and stamina. And everyone here knows more containers are on the way.
And when we're finished with a can, we push it off and grab another one. And we start the whole process over again.
Each of the 3 size groups must head off into completely different conveyor universes, each designed to handle their unique dimensions and weight. Smalls are the easiest to handle. Workers unload the smalls onto a conveyor belt in the wings, and they're sent on their way. Parcels are a little trickier to tackle. These 6-sided boxes range in size, with dimensions just over 1 meter long and weights up to 45 kilograms. Too big to group into easy-to-handle bags. Parcels have to hold their own throughout the system, flying solo along the conveyor belts. To keep track of these solo flyers, engineers needed a way to get a complete read on each parcel's vital statistics. they created a master machine that handles dimensioning, weighing, and scanning all at once. The DWS for short. The DWS is the first machine at Worldport to give these unidentified objects a complete shipping identity. As parcels hit the conveyor belts, they pass through the DWS. In mere seconds, an embedded scale gets an accurate weight. Then the DWS goes high-tech. A series of cameras and lasers allow the machine to take the height and width. Most important of all, the DWS scanner identifies the parcel's zip code. This information goes to a central server. The server makes a quick calculation based on the volume of total packages shuttling through the Worldport system at any given time and determines the specific route the parcel should take. The goal? Avoid conveyor overcrowding, weight overloading, and traffic flow collisions.
On any given night, 2 nights in a row, that package may be going to the same place, and it may take 2 different routes. And that is the great thing about the technology of Worldport, is that it finds the most efficient route and gets it from point A to point B in the quickest manner so we can make our time constraints.
As the packages leave the DWS, the conveyor belts adjust automatically to send them in the right direction. Like changing the angle on a treadmill, a mechanical device called a vertisorter raises or lowers the conveyor belt surface.
The vertisorter is simply just a belt that flips up or down. We have 2 of them. The first one's going to, based on the destination, either stay flat or raise up so it can go through, but it's going to split it 2 ways. And then the second vertisorter is going to split another 2 ways based on the destination of that package.
But irregulars demand the human touch. These large unwieldy packages can't fit on the standard conveyor system. Irregulars routinely put this ultimate factory to the test. The first task is to route these exceptions to the rule away from the standard items. This moving band ferries irregulars straight to a special processing area where they'll get more personal attention to keep them on track. It's all part of the unique engineering that makes Worldport an unusually flexible facility, accommodating the fastest automation and the most painstaking human processing, all under one roof. But the shipping giant had far more humble beginnings. UPS began in 1907 when 19-year-old Jim Casey borrowed $100 to start his own Seattle-based courier business. UPS moved its center of overnight operations to Louisville in 1982, but shipping was still a simple operation with scattered warehouses and manual sorting.
Our facility itself, we started a couple of buildings that just happened to be here. We kind of piecemealed them together, some old warehouses, and we were manually sorting packages.
2 decades later, the dream of Worldport, the ultimate state-of-the-art mega factory, was born. It took nearly 3 years to build and doubled the facility's size. It was a gamble, but in the end, Worldport paid off, increasing capacity by nearly 40%. Now, they can process more than 300,000 packages an hour.
We made the decision that we're not going to piecemeal anymore. We're going to build this large standalone facility. And we did that. We opened what you see now as Worldport.
The core's the heart and soul of Worldport. 1,000 meters across, 4 floors towering nearly 25 meters high, big enough to house 39 jumbo jets. Any package that lands here has to move through this massive maze and get a place on the right outgoing plane. And hundreds of thousands of these packages have no time to waste. They're stamped with 3 critical words: next day air. Managing this sheer volume requires agile hands, an eagle eye, and the most state-of-the-art automated technology available. As our 3 packages, a small, parcel, and irregular, make their way into the fray. every night, Worldport processes nearly 500,000 smalls. They've got to work fast or risk a cardboard logjam. Conveyor belts take the smalls straight up to the core's 4th floor. Workers debag them and drop them down a chute, where they'll soon be individually divided and sorted.
The trick to this job is basically just getting everything off the belt so the belts don't overload. That's the problem that we have.
The smalls now catch a ride on a different conveyor belt, ferrying them to a station called the induct area. At the induct area, Worldport team members quickly place the item's label up on a moving track over 3 kilometers long. This unique snake-like conveyor is called a tilt tray sorter. It boasts over 6,700 package holding slots, each specially designed to hold one item at a time. But a face-down package may as well have no label at all. The tilt tray's ingenious design is all about routing items automatically as fast as possible to their proper destinations. Here's how. The tilt tray operates by a computer hooked up to a camera. As each package hits the tilt tray, they pass through this specially designed camera tunnel. Inside, state-of-the-art laser light readers scan the smart label in nanoseconds and identify the package's zip code. The camera instantly sends the information to servers in the Worldport's conveyor belt control system, telling the conveyors exactly how to maneuver each package into the correct receptacle, separated by destination zip code.
That laser picks up their destination and then it matches it to these bags, and that's what makes the boxes drop into the right bag.
Whether it's going to 90210 or the Pentagon, each tray gets a signal when its assigned zip code is approaching. It dumps the parcel into a power bag. The pace is fast and furious.
Peak time around here can get pretty crazy. The hardest part about this job is there's specific destinations that can get hit a little harder than other destinations, and if you happen to work in that area, then you're going to have a very busy day.
But even the most cutting-edge technology needs a backup plan. If the camera tunnels can't read the labels, the package can go AWOL. To solve the problem, UPS designed an intervention process called telecoding. If a smart label is damaged, or the package label is handwritten, or has a bad barcode, cameras register the problem and send an image of the label to the telecoding department. Here, a damage control technician looks at the label on a computer, then manually assigns a zip code to the package. From then on, the system will recognize the item as a smart package.
Basically what telecode does is it takes an unsmart or unreadable package and makes it smart and readable. So once again, the technology can do what it does and get that package to where it needs to go in the most efficient manner.
Parcels, 6-sided boxes up to 45 kilos, find themselves in a different sorting universe. These diverse medium-sized packages make up the majority of UPS shipments, and they get the fully automated treatment in the core's lower floors. Here in people-free sorting zones called the primaries, kilometers of conveyors equipped with dozens of cameras and barcode readers move packages toward their appropriate destination.
Once the package is properly read going through the primary camera tunnel, the system now knows where that package needs to go in order to go to its outbound destination.
Getting packages onto a conveyor belt is relatively simple, but determining the precise moment when they need to merge with a different belt is another matter. Too fast and packages can jam up or slam into one another. Too slow and they lose precious time. To tackle the problem, Worldport engineers created the ultimate intelligent machine, the posi sorter. Posi sorters are built right into the conveyor belts themselves. Like giant automated snakes, posi sorters help shuttle the parcels through the core.
The system will receive a successful read from the camera tunnel, and from that point it will track where that package is and along its travel along the posi sorter.
Here's how posi sorters work. Posi sorters use embedded conveyor nubs called pucks to keep packages in line and safely spaced. Any package can shift in transit, becoming a loose cannon in the system. To respond to dangerous shifts, a camera eye determines how much space a package is taking on the belt and how many pucks it'll take to nudge it off. When the conveyor comes to an intersection, the pucks slide over and push the packages in the appropriate direction.
This is critical to Worldport because of the fact that there is no human hands touching it. It takes all the air out of it, the human air out of it, and it's done through automation and the smart label.
Another way UPS prevents collisions and conveyor belt chaos is through road etiquette. Specifically, a computer oversight system nicknamed Polite Packages.
It's almost like merging on a highway. You don't just take off when there's cars coming down. You wait until there's an opening.
Polite Packages uses cameras, embedded scales, and scans to gather information about each item as it moves along, keeping packages from colliding by sending the data back to a master computer. The computer gets a perfect up-to-the-minute picture of what's happening on the conveyor belts at any given time. At the first sign of trouble, the computer can order a conveyor to stop until a potential traffic jam clears.
What would happen if it didn't exist? This would have to be done manually. Basically, in this system, we can sort a package from the unload to the outbound without a package touching.
But even the most streamlined automated system breaks down when faced with these shipping troublemakers, the irregulars. Irregular items' unpredictable and asymmetrical dimensions can easily hit obstacles and get stuck. Worldport rose to the challenge through human intervention. Irregular items have their own system in the core to keep even the most eccentric items in line. It takes bins, a trained technician, and a traffic light. First, workers manually scan and place items inside large plastic tubs that travel on tracks. Designers modeled these tubs after airline baggage sorters. They help keep oddly shaped items under control.
Rollers, so you don't have to pick it up, really helps track it. Slide it in, make sure it's in the middle and secure. Then you come over, of course green means go, and it goes on its way.
The irregular tubs speed along at a fast 300 meters per minute. They ride tracks similar to a roller coaster. When the tub gets to a junction, the programmed computer system already sees them coming and changes tracks like a railroad, transferring the tub to the correct route back to the Worldport wings. The whirlwind trip through Worldport's almost complete. But the smalls, parcels, and irregular packages still have to race back to the wings to load on to waiting planes. On their way to their ultimate destinations, and every second counts. The sorted parcels and smalls ride back to the wings on the posi sorter conveyors. Pucks nudge the items into container chutes designated by final destination. The chutes lead to collection areas where workers manually pack items into zip-coded aircraft shipping containers. Packing is as much an art as a science.
It's a lot like Tetris in that you just, like, you're hoping that you get a certain size box because you really need it. It's physical stress messing with the big boxes, but it's mentally exhausting. Just because, you know, if you ship a plane out of here late, then everything's gonna go bad.
Irregular items still need special attention. They re-enter the wings and travel to their assigned sector. Workers remove them carefully and place them on conveyors heading to the irregular load stations. Here, team members physically walk the items to the appropriate shipping container. It's 1:45 in the morning. After only 45 minutes, high-tech scanning, dozens of sorting steps, and computer quality control, the packages are packed for their destination. But first, they've got to get safely on the right planes and stay intact through thousands of kilometers in the sky. The pressure's on as the UPS tarmac crew gears up for a fast load-in that's got to go like clockwork. Like a mirror image of docking in, workers use K-loaders to load items into waiting airplanes. But this time, weight matters. Improper packing can dangerously throw off a plane's center of gravity and stop it from taking off. Precise weight calculations influence every decision in packing the aircraft. It's part of Worldport's final finesse and an integral part of running their massive cargo airline at peak capacity. But no matter how phenomenal the fleet, UPS needs top-notch pilots to fly them. All licensed commercial pilots must undergo FAA-mandated annual training.
We did have one procedural mistake where we didn't activate final.
At UPS, it all happens here. This in-house pilot training facility is the closest thing to flying without leaving the ground.
This simulator can simulate any event. And it's okay to make a mistake, because when you make a mistake, you learn from it, you grow from it.
Computerized 3D flight simulators put pilots through rigorous tests and training that can mean the difference between life and death.
You make a mistake here, you can make it safely and walk away from it, whereas in the real world, you might not be able to walk away from it.
The most intense pilot simulation is called Level D. It creates an experience so accurate, the FAA recognizes hours logged here as actual flight time.
The algorithms are just phenomenal. You want to go to San Francisco, there's the San Francisco Bridge. You want to train in Shanghai, China, we'll put you in Shanghai.
So takeoff thrust?
During this event, what we're going to simulate is the aircraft on a takeoff roll. The crew's going to experience a right engine fire.
Thrust set. Running one's checked. Rotate.
The crew validates every procedure to ensure that they're going to shut down the correct engine and not mistakenly shut down an engine that's still operating. So everything is checked and confirmed, and the instructor is ensuring that that's exactly what's being accomplished.
Flaps, 30-30 green light.
Auto discharge light on.
Transfer. Nice job.
But there's one factor that's always out of UPS's control: the weather. Worldport decided to take on Mother Nature single-handedly. One thing's clear: when it comes to delivering packages safely and on time, in all conditions, knowledge equals power.
Whether it's thunderstorms in Cologne or typhoons in Taipei, as a Worldport meteorologist, I need to know.
Step inside Worldport Weather Command Central, a special center dedicated to round-the-clock meteorology monitoring, backed by cutting-edge technology, from state-of-the-art satellite tracking to prediction and forecast software programs. It's part of the UPS Global Operations Center, located across the street from Worldport. Here, 600 staff members, including meteorologists, provide weather forecasts day and night.
From 11 p.m. to 4 in the morning, that's our critical time. We need to know what's going to be happening within an hour. And other sources just don't provide with that degree of accuracy.
In fact, UPS Meteorology can forecast and track virtually any weather anywhere in the world. Trained teams analyze satellite images fast, coming up with alternate routes for grounded or rerouted planes. It's a life and package-saving precaution.
We have all the weather reports, we have all the computer forecast models, and we can slice and dice that information any way we need to.
And for each plane that takes off and lands at Worldport, the air team has 3 constant goals: safety, fuel efficiency, and on-time performance. One solution has to do with how pilots touch down at this ultimate factory. Worldport pilots use an unusual technique to descend from the sky. It's an approach method called continuous descent, and it calls for pilots to switch to idle power as they glide down smoothly. Continuous descents take advantage of gravity as pilots minimize fuel intake and descent speed, converting their jet planes into high-tech hang gliders. Continuous descents allow for energy-saving landings, using minimal power, navigating the runway both efficiently and quietly.
What we want to be able to do is to have the aircraft fly the most efficient place for us to fly, all the way down to the runway, thus saving us a lot of fuel, a lot of time, and making us much better neighbors by reducing our emissions and our noise.
(2:15). 8 hours since our high-priority packages left their local hub and made their journey through Worldport's mega maze. Ground crews work fast and furiously. Many of these items have to get to their final destination in mere hours. The last of the cargo loads in. The maximum 62 fully loaded containers can add up to over 115 tons of payload on board. The planes are cleared for liftoff. It's time for a tricky maneuver called pushing back. Revving jet engines can blast out 100-knot exhaust winds, hurricane-level forces that can damage anything in their path. To steer clear of any danger, UPS planes avoid backing up. Instead, technicians manually turn and push idling planes to a runway, keeping people and property safe. But Worldport's crowded ramp can be a dangerous obstacle course.
You get so close to the buildings when you're marshaling it out, and if your partner's not paying attention, they could hit the building because the way it pushes back.
One false move pushing back, and these massive airplanes can hit something. At over 350 tons, even a small bump can do dangerous damage.
You gotta watch them and make sure the pushback guy's watching you, make sure you stop them in time so that nothing hits the plane.
At last, with all the cargo aboard, the plane is off, bound for its local hub destination, as this super courier heads into the final countdown. UPS technicians use a K-loader to empty the aircraft and tugs to drive the package-loaded cans to the local UPS processing center.
The physical aspect of the job is what I like. It keeps me healthy and fit. I don't have to go to the gym every night. I get a good workout.
All local centers work like mini Worldports. Workers unload newly arrived packages and run them through a series of conveyors. But this time, a zip code isn't enough info to go on. Packages load into a waiting fleet of over 200 trucks, according to precise destinations, from neighborhoods to huge office buildings to specific street numbers. Once these famous brown trucks hit the road, communication's a route-saving lifeline. One of the biggest challenges UPS faces is keeping drivers connected to their local hub. At any moment, critical changes in pickup schedules or priorities can reroute a driver's entire itinerary. Engineers examined satellite and wireless technology and came up with a ground shipping savior. It's called the Delivery Information Acquisition Device, or DIAD. At first, DIADs were relatively simple, but they've evolved into a technological wonder. DIADs use wireless connections to tap into a centralized route and tracking database. The handheld devices give drivers critical info, from priority alerts to itinerary adjustments when they need it most. Built-in GPS even helps a lost driver get back on track, getting packages to the correct destination on time. DIADs are so effective, there are over 80,000 of them now in daily use.
The DIAD is used as a way of scanning and tracking and keeping track of what I have on car, the signatures that I acquire from the customers, and completing and giving tracking information to shippers as well as the customers on the delivery point. It's just a valuable tool, and I couldn't do my job without it.
The DIAD also acts like the ultimate chess player, storing delivery routes many moves in advance. Here's how. Before the driver heads out each morning, the DIAD loads up with navigation information using a computer system UPS calls Package Flow Technologies. DIADs work with this software mapping system to come up with a game plan for drivers to tackle any problems on the road. The system's also designed to save fuel on top of time. There's just one catch: no left turns. Incredibly, you'll almost never see a UPS driver make a left.
We pride ourselves on efficiency and no left turns when we go out and look at the area that we're in. We know we can always make a right turn. So we try to build our plans and build our delivery trace, meaning where to go next on making right turns, because to make a left turn, you're stopped and the efficiency just gets a little bit lower. So we try to build it to be as efficient as possible.
It helps to streamline and make you more efficient. See what I mean? There's another right-hand turn. All right turns. You gotta love UPS.
The no left turn philosophy is a simple strategy that pays off on a huge scale. Drivers spend less time waiting at stoplights and more time delivering packages. The time saved driving also adds up to fuel saved, a benefit to both the bottom line and the environment. It's another critical element to UPS's package flow technology. In all, they calculate these unique strategies save them well over 30 million kilometers on the road and more than 100 million liters of gas each year. As our 3 packages head off to their final destinations, their journeys are almost complete. It took a cross-country trip to a 240-hectare mega facility, hours traveling through conveyor belt jungles, sorting super machines, supersized scanners, barcoders, ball mats, countless team members, and exactly 14 hours. As the next day air clock stops ticking, driver DIAD machines confirm on-time deliveries across the board. Mission accomplished. A critical contract, a family heirloom, and a telescope in safe hands. And all in a day's work for the super factory, UPS Worldport.